So in this video we're talking about how parabolas are used to model real-life situations. And what we're talking about here is how pretty much parabolic reflectors work. So parabolic reflectors have cross-sections that are parabolas, obviously. Here's a cross-section of a parabola, a parabolic reflector, a parabolic reflector. And two things happen when you have a parabolic reflector. Essentially, so that all incoming rays, so as the rays travel in, they bounce off the parabola and go to the focus, which is right there. Also, when you have a parabolic reflector, any rays that are being transmitted away from the parabola, they're going away from the focus, they hit the parabola beam, they go out parallel to the axis of symmetry of your parabola. So this is essentially, in a very concise nutshell, how satellite dishes work. That's the most obvious example of a parabolic reflector. So just kind of a little FYI tidbit. Now let's do a problem. In example 11, we're talking about sunfire, which is a glass parabola used to collect solar energy. The sun rays are reflected from the mirrors on the parabolic reflector toward a boiler located at the focus of the parabola. When heated, these boilers produce steam, which powers an alternator to produce electricity. So just again, how a parabolic reflector is transmitting sunlight. The sunlight comes in and hits the dish and is transmitted to the boiler by those properties. We just saw it. The boiler creates steam, which powers an alternator, which creates electricity. So kind of neat. What we want to do is write an equation for this parabolic reflector's cross-section. So obviously this parabola opens up. So since we know that the parabola opens up, we know a couple things about this parabola. Number one, we know the equation is x minus h squared equals 4p times y minus k. We also know that if we assume that the vertex of the parabola is at 0, 0, which we're going to assume that just to make life easy. So if the vertex is 0, 0, then the focus is at 0, p, okay, which is going to help us. All right, so again, we're assuming that the vertex is at 0, 0, so we know that for this parabola, we already have our h and our k. We also know that our focus is at 0p, so if this is x equals, so here's my axis. Okay, so if you imagine this is actually sitting on the axis, that means the boiler, my focus, is sitting at 0, 10. Well, if we match that up with our rule about the focus, that means P has to be 10. Since we now know H, K, and P, we can write the equation for this parabolic reflector. So we have x minus 0 squared equals 4 times 10 times y minus 0. Clean it up everywhere that we can, so obviously we just have x squared equals 40y. That's the solution to part A. Write the equation. Now we want to know how deep this dish is. Now, don't just think that, hey, the depth is 10. No, because, believe it or not, this boiler is sitting a little bit above the top of the dish. So it's going to be less than 10. What you might not be able to see anymore on here, but you should see in your notes, is that the entire width of the dish is 37. So what that tells me, since that width is 37, from here to here is 37 divided by 2. So that's my x direction because I went to the right, so 37 divided by 2. I'm going to use my calculator just to save a little bit of time. I couldn't do that in my head, but why? Why do it in your head when you can use the technology? So that's 18.5. So just again, going from the origin to the right-hand side of the dish is 18.5 feet. All right, well, I'm going to take that x and plug it into the equation that I found in part A. The reason why I wanted x is because it's asking for how deep or how far up and down the dish goes. Obviously, how deep it is or how far up and down it goes is a y direction. So I need to plug in for x and solve for y. So I'm going to plug in 18.5 squared equals 40y. Let's figure out what 18.5 squared is. This is going to be a pretty big number, so I better use calculator. So 18.5 squared is 342.25 equals 40y. Again, I want to get y by itself, so I'm going to divide by 40 each side. So y equals, I'm going to do this in my calculator. So divided by 40. And it's about, say, 8.56 in my units of feet. So in part B, I found that the dish is approximately 8.56 feet tall. So we can see how once we know the equation, we can apply this to real-world situations using parabolic reflectors. And that wraps up our videos about parabolas. We're going to be doing the next set of videos that's talking about circles. So look forward to that.